Welcome back to the Darius Gant Show. I'm your host, Darius Gant, as well as founder and CEO of Tesoro AI, where we help innovative founders and executives build AI solutions and AI teams. On this podcast, we focus on cutting-edge technology, more specifically, artificial intelligence. By getting up close and personal with these visionary AI founders and executives, we get real-world insights into the problem that artificial intelligence are solving, as well as how they're actually building and scaling their businesses. In this episode, we sit with Max Versace, who is the co-founder and CEO of a company by the name of Neurala. Neurala offers a vision-based AI tool that assists manufacturing companies in the vision inspection process. Its capabilities allow for detecting anomalies and product variations. Max himself has a pretty decorated AI background. This includes his work with DARPA and NASA to develop a new type of artificial neural network that can learn in real time. If you or your team is considering building an AI solution, be sure to reach out to the team at Tesoro AI. We've assembled leading experts in data science and machine learning. So whether we're talking about AI strategy, software development, staff augmentation, or data labeling, we've got a strong team here that has your back. Head over to www.tesoroai.com. All right, I know you're ready for the episode. Let's hop over and chat with Max. Thanks for joining us on the show. We appreciate you taking out some time to chat with us today.
My pleasure.
So where I wanted to kick off here is really, learn some more about your background. And I saw you've done a doctorate in, you know what? I'll let you introduce that piece because I don't want to butcher it. But yeah, we'd love to learn more about your background before we hop into, talking about Neurala.
Absolutely. So I was born and raised in Italy. I came to US in 2001 for my PhD in artificial intelligence. And after a few years, I went to a postdoc and professors in AI. And during this path, I met my co-founders, an American, Heather, and a Russian, Anatoly. And around 2006, we came together because we had a problem. So we were building this massive brain algorithms or algorithms that imitate aspects of learning, perception, motor control, and other brain functions. And we were building these very large deep learning models or neural network models, and they were really slow. So we came up with a patent back in 2006 on using GPUs for deep learning. And we started a company, Neurala, to contain that IP and some other patents that we wrote while studying. And during the process, we became friends. We started a lab sponsored by DARPA that gave us some funding to design, to take our research a step further, design, very large scale brain algorithms to able to control robots. And almost immediately thereafter, NASA contacted us to use that technology for a new generation of robots able to navigate by themselves in a foreign planet. And in 2013, we got funding from NASA, DARPA, not DARPA, Air Force. And we had enough money to basically say goodbye to academia and started the company, enter an accelerator. So at heart, we are three professors of AI. So I've been in AI for like 25 years. That's all I know. And then, we scaled up our technology. We designed our unique artificial intelligence that is able to run. As you can imagine, NASA gave us very severe power budget and constraints. So we couldn't use traditional methodology that everybody uses today, like backpropagation on those algorithms that take a lot of time and data to learn. So we had to design a completely new way of doing learning, and that's what we have as a technology. So we are pretty unique in terms of technology and approach. And we ended up deploying our AI in about 60 million devices overall, ranging from camera, cell phones, drones, robots. And now we are transitioning into a new generation of the company where we are productizing vertically in one aspect of the application that where we have received the biggest pull from the industry, which is visual-based inspection, in particular in the industrial sector, which is, with that word, like encompass a huge amount of the economy. But we are, in theory, we are verticalized, but it's a huge vertical.
Yeah. So if you think about the industrial sector and where you all fit, well, if we back up first, why the industrial sector? Why did you decide, this is the perfect industry for us to go in and provide a solution?
Yeah, so it didn't dawn on me for a second that's where we will apply the biggest amount of our technology. But if you think for a second, 10 years after we started our journey, it's obvious, right? So we design this very lightweight algorithm that are able to run on a tiny processor like a single CPU, and are able to learn very quickly from many, like we were powering a robot, so the AI was doing many different things, but let's focus just on the camera. So you can show something to the camera as you're navigating around on Mars, right? And the robot is learning in real time and updating its knowledge. And so, strong with this technology, we looked for applications. And with our surprise, there were not millions of robots that we could deploy it on Earth, right? So there was a very tiny robotic market, a very nascent drone market, mostly for, you know, non very useful things like taking selfies, right? And so we looked for a particular angle of our technology, and we ended up in cameras, mostly consumer cameras, but also in inspection robots that were applying their technology for inspecting, both in robots and drones, inspecting infrastructure. And so in 2019, we have taken our technology and put it into a platform that will enable anybody with zero understanding of AI to build these models using our tech and deploy it. And the majority of the pool came from the industrial sector, so from large corporation or even smaller, that wanted to build artificial eyes to improve the quality of their production, catch defects, and essentially augment the human worker or put eyes where human workers were not available. And so your question is, how did you end up from a Mars rover into an industrial machine?
Right.
And the answer is really simple. Those are the robots that are most popular on Earth, right? So if you're looking for machines that need at the edge, right, mostly edge artificial intelligence, the biggest deployed number of machines are actually in manufacturing, right? So those are machines that work 24/7. Maybe they take a week off, right? So a typical industrial machine works day and night with the week off during the year for maintenance. And so those are the machines that are around on Earth, right? Whereas the Mars, we send one robot on Mars every couple of years, but that's really, aside from self-driving cars and all those future technologies, but we as a company need to make money today. So today, the industrial manufacturing has the biggest amount of machines available. And so we ended up there. And now when I tell it to you, I say, well, that makes sense, but it wasn't obvious when we started the trip.
Well, what I find so interesting about that, right, is I guess if you look at kind of a traditional approach to creating a product for a market, right, you generally, you're trying to understand where the pain point lies and then think about a product to fit, before actually building. You guys, having come from what you did for NASA, right? You had a product, and then it's like, look, we have this great technology. We know there's value. Let us, triangulate where we think the perfect industry is that could use this technology. And it's interesting that we kind of took an approach of, well, let's look at total addressable market, right? NASA's going to send one robot up. Who has a ton of robots that we can deploy this technology into all of their robots? Because you look, at the end of the day, we have to sell our technology and generate profit from that, right?
Yeah, and as you say, Darius, it's exactly true. So there are multiple ways in which you can build a company, right? And we have done. I've started a company with my wife many years ago. We were still in Boston University, and let me tell you this quick story, which is the opposite of Neurala, right? So I was driving a Vespa. Being from Italy, I drive Vespas all over, right? And the gas price in 2004, I think, was up to a ridiculous amount, and people started to, as opposed to making fun of me, they started to ask, "Where did you buy that scooter?" And so the problem that they were trying to solve is the huge amount of money that they were spending in gas. And so we put together a website. We started to sell scooters online, and in 3 months we sold the company, right? So it was addressing a problem, which is how do I reduce the cost of transportation? And so that's another way to build a company, right? You address a specific problem. In this particular case, we built a solution for NASA, right? And so it turned out, as you say, though, that the total addressable market for a NASA rover was one every couple of years. So
Right.
we looked for other areas of application, and it was really early times, at the beginning of 2012, 2013, when we got out of academia. Really, there were two kinds of robots. One were the industrial robots inside, say, car manufacturing, right? So those were the biggest amount of robots, but they're really like, it's not a huge addressable market. And then there was a nascent, drone market and the small robots market, mostly toys or telepresence robots. So as a company, we had to look around and found the right fit for the technology. And that's not easy, especially if you're starting as a technology company rather than a solution for a problem.
Right. And so, if we think about Neurala, focus on visual inspection, we'd love to hear more about, the actual visual inspection piece. What type of faults they're detecting, like what type of actual things are you leveraging the technology to see, to catch, to prevent?
Yeah, absolutely. So one of the biggest drive for visual inspection is something that was extremely urgent for manufacturing, which is nobody wants to work in factories, right? If you have a choice with the rise of the sharing technology and societies and the economy, people would rather drive an Uber than sit in a factory for a night shift. And so there was a decline in the workforce. Then coronavirus hit, and many companies, they were completely unprepared, as we all were. But manufacturer found an additional struggle, disruption of the supply chain, but additionally the need for having workers actually in close proximity to each other, building the products that we need every day. And so they couldn't stop producing, but they couldn't put all these people together. People were unavailable, were sick. There was, all of a sudden one person was sick and everybody had to go home. So they had an urge to accelerate their initiatives to put artificial intelligence at work where humans cannot be. And so this was basically pressing the accelerator in the adoption of the so-called Industry 4.0 initiative. And the applications are really I would put them in two buckets. One bucket is where usually people would think that quality assurance is inserted, which is in certain spots where the product is assembled, for instance. But then manufacturers start to think of other ways in which they can put artificial intelligence at work. For instance, as if you're building a food product, right? So if you're building bread or dog food or any product that has ingredients, raw ingredients, they're starting to think, well, I can start to put these inexpensive cameras at the beginning and at the very end, not only in the middle of the production cycle, so I can catch, for instance, if there is a contaminant coming in, or I can check if there is a mislabeled product. And so by putting AI at work in multiple places, they're essentially slashing the problems that the typical manufacturer has, which is recalls, wrong products, mishandling and the wrong labels and products going into the wrong pallets. And so that's huge savings. And at the same time, they are automating a process that was very, very dependent on a scarce workforce. And so the application range from building integrator circuits to food, packaging, and automotive, and the usual you can think fabric and so forth. So it's virtually in almost every production that you can think of.
Yeah, and if we're thinking about quality here in terms of inspection, I can imagine if you're able to properly use, machine learning, from that inspection perspective, you're going to be able to detect things that even a human can look at it. Like if there's two words transposed on a label, right? Maybe a human, we automatically correct that with our brains, right? But a machine's not going to do that. They'll see, okay, that's actually spelled wrong or misplaced.
That's true. And we were speaking with one of our customers on Friday, And he noticed how our technology was able to catch things that the human wouldn't even catch. And you can understand why. I mean, no human being wants to stare at certain things 8 hours per day. I mean, our attention drifts, and in a sense, our industrialization has built dehumanizing jobs for us, and artificial intelligence is kind of correcting that. It's sort of doing the opposite of what people think, right? So the people think of AI as enslaving us, but really, if used properly and with the right mindset, it's actually freeing us to be more human, and having a machine do the machine job, so that we can we can do things that are a little less repetitive or boring.
Yeah, yeah. So from that perspective, when you are actually, when Neurala is actually deployed, at a customer, is it within their existing camera? So is it software that's loaded into their existing camera, or are you providing some type of robots?
Yeah, so first of all, we are a software-only company, so we provide only software, and then usually we go to market in the industrial manufacturing sector with system integrators. So most manufacturers, like for instance in the US, there are about 310,000. Like out of those 310,000, about 300,000 buy their visual solution to a system integrator, which is essentially I don't know, it's like the plumber for a house, right? So few people change the plumbing by themselves. They call the plumber, say, I have something to fix. The plumber goes and fixes it. So the equivalent for the system, for the manufacturer, is the system integrator, who goes there and basically gives in the whole package a visual inspection system that has not only our software and the camera, but also everything else that is required to make the system work in a fairly complex environment, where you have to have the right connectivity, the right camera, the right lighting, and so forth. And so we go to market most often with these system integrators, though at the same time we interact with large manufacturers. We have this expertise in-house, right? So you can imagine, Fortune 100 companies, they have pretty extensive teams in-house to do this. And then at the same time, we also sell our technology through some OEM, where and we are going to do some announcement soon in the next couple of months, where our technology will be embedded at the source into some device, some cameras that will be sold directly to customers.
Yeah. I'm curious where you got the initial data from to be able to lift the solution, and where you able to do some of the things that you had from the work with building for NASA, right?
Yeah, so that's the trick. We don't need any data. So all these the gym, and I know you were a sport guy, so all our workout with NASA was designed to was instrumental to design a system that can be trained really quickly without AI expertise. And so we let the user train the system. We don't pre-train the system, even because of the fact that the system cannot really be pre-trained, because the applications are so unique that only the customer data can really express the variety of the usability of the software. So, for instance, if you're trying to detect anomaly in a carpet produced in a factory in in Texas, the camera arrives, the software arrives, and then the operator can run the production for 2 minutes, gather enough data, train the system, and then deploy. And in 5 minutes or 10 minutes of training, you are done, right? So the training itself takes just a few seconds, but it's trained on your own very unique data.
Got it. And then they would go, or do they have to, or they go through and label, hey, I guess, what's an example? Here's a jar with a crack. This jar is perfect.
Yeah. No, so in reality, our software can work in a so-called anomaly mode, which can only be fed good data. And so you can basically feed, say, carpet or auto parts or, a bottle or so forth, like the right product. And then the system learns what a good product looks like, and then tells you if there is an anomaly. And we have launched in beta a layer that we call explainability, which tells you where in the in the product the most likely spot of the anomaly is located. But that's a unique feature of our technology, because most of the time manufacturers have very unbalanced data sets, right? So you have a huge amount of good data and then occasional crap coming out of the production line. And so and going back to NASA, this technology that we design fits really well with this environment, because we can train it only with good data. We basically function in a traditional supervised fashion when we have enough data, but if we don't, we can train only on good data.
Okay, right, and then you can apply anomaly detection. That makes a lot of sense. From someone who comes from more, of a research background, right? When you are in research and you're thinking about novel ways to leverage artificial intelligence, right? There's this gap between, what would be nice to create and what you can actually commercialize, right? Are there people, who have that research background, who have a gift, right, for being able to commercialize products, right? To take a novel idea and actually turn it into a product?
Yeah, I mean, I think that the major skill that you actually learn, you can learn, it doesn't have to be innate, is basically discipline. So as a researcher, your pedigree is to think about the next big, impossible, hard to do thing. And,
right.
And sometimes when you have to deploy a product, that's really not a paying dividend, right? So you have to have a more of a balanced diet, if you will, right? So you have to have the technology that makes you different, but then there are so many things that you have to do that may be not super interesting from the research perspective, but they are solving a customer problem.
Mm-hmm.
And so the right attitude here is to keep at bay your wildest interest, right? That might lead you to build a very cool feature, a very cool piece of tech that might have very little impact on the choice of a customer to pick you with respect to a competitor, right? And so that's the balance, right? And it's you have to do both, right? You don't want to be flat in terms of your AI innovation, because otherwise you might disappear into irrelevance. But you don't want to be just doing science experiments without relying on customer-driven features, right?
Yeah, and I'm curious how you all, post the NASA project. Was it just you and your other the other two founders, was Heather and I forget the name of Anatoly. Yeah. So was it just you three as a core group once you launched Neurala, or did you have a kind of still a team, but a team?
Yeah, so we in 2006, actually before NASA, it was just the three of us.
Okay.
So we incorporated just the three of us, and we were just playing around as we were doing our PhD, mostly as a curiosity. But then during the time elapsed between 2006 and 2013, as we progressed in our career at the university, we built a lab at Boston University, which was called Neuromorphic Lab.
Okay.
And mostly sponsored by DARPA and NSF. We built so-called neuromorphic technology, which neuromorphic stands for is composed by two parts: neuro and morphe, which is morphe is of the form of neurons.
Okay.
And so we were designing software and processors, in collaboration with a hardware company that mimic the way the brain works, right? So non-conventional processor and non-conventional artificial intelligence that went beyond the sort of the traditional multi-layer perceptron and backpropagation that still dominates the industry. And so we had a team of researchers in the university, and then slowly we shut down the lab and transitioned a few of these, the best of these people into the company, and then the rest went their own ways. And so we sort of sucked in a few of these people from the university as we discontinued the lab and move on.
Yeah. Now, did some of those folks already have kind of that, because now we're talking about building a software application, which has its front end, which has its, back end. Did those people have that skill set, or did you say, hey, look, let's go out and bring some more folks in who will be able to take care of this, this piece?
Yeah, absolutely not, right? So they were lacking many skills. So we immediately surrounded, the core research team by an engineering team. And at the beginning was really, put together with some speed and glue. And, we really took a step when we brought in an experienced VP of engineering that, started to create more discipline in the team. And so, from that time, we started progressing. And now we are at the point where we do a good bug-free release every 2 weeks.
Yeah.
But it took us a long time to get there because, coming from academia, the code was not necessarily all the time, high quality, right? But
yeah.
Now it has really evolved, and researchers have taken a step back from the hardcore engineering, and they work in collaboration with the hardcore engineers to build a piece of R&D that is immediately integratable into a releasable software. So that that takes a long time, but it pays off because you're building a very cohesive team that works really well together.
Yeah. Yeah. Well, and what I find really interesting about that, and we often see this, right, a lot on the Tesoro side. It's like, when you have people who are very research focused, it's like, there are a lot of capabilities for what could be done. So you kind of have to marry that with someone who's on the product side and say, you know what? Yeah, that's going to be great in 5 years. But we need to get, need to deliver value right at the end of the quarter. So, give me a fraction of that, and then we'll keep working on the rest as we go.
Yeah. I mean, our CTO tells us all the time, research can never be finished. It can only be terminated, right? So you end up, you might end up in this huge spiral. So you have to quantize your effort, right? So they have to have a particular beginning and a particular end within a temporal lifespan that is consistent with human life and production and software releases. And so that's a challenge. So you have to chop it off.
Yeah. So, I'm curious now, after you built the product, right? You've got some value there. You've identified a market. Now you're kind of looking at working with OEMs, looking at working with system integrators. What was the process for you in terms of getting in contact with them, making a pitch, communicating value of what you all have created?
Yeah, so we worked, we have a very experienced sales team. And so with the marketing team, they really drive this process. So and we did our mistakes as well, right? So at the beginning, we thought of a go-to-market that was mostly direct to manufacturers, and we learned that the way this manufacturer really buy is mostly through system integrators. And so we adjusted our strategy, and now we have understood how the system works and how to reach out the customer, where to find them, how to pitch. And it's mostly by experience, right? So you do a few pitches, you get it right, a few right, and you get many wrong. You analyze what happened, and then you iterate, and your performance goes up. So pretty much like a neural network. Yeah. And so our brain also learns by doing mistakes.
Okay. And what's it like? I mean, manufacturers, right? I imagine you could probably go into Google, type manufacturing companies in the U.S. and the names of them will pop up. Is that kind of the process when you realized, all right, well, we need to pivot and be pitching to system integrators? Were you able to get introductions there, or did you kind of start from ground zero and say, all right, well, here are the folks that we need to be targeting in our outreach?
Yeah, so again, it's a function of knowing the market, right? So at the beginning, you might come up with an hypothesis, but then you refine it over time. So there are many sources of data that you can tap into to find the right, system integrators and partners, value-added resellers that you can go through. And so it's really a function of learning from your daily interaction and finding the right data sources, which is probably the treasure of the marketing and sales and marketing team.
Yeah, yeah. Was there, if you thought about personnel, right, as it relates to actually getting in and having those conversations with that core marketing group, is there a certain type of profile where you were saying, hey, this person would be valuable in terms of helping us to get in the door? Did you yourself say, all right, well, I need to pitch myself as the founder to get in the door here?
Yeah, I mean, it depends who you're talking to, right? So if you're speaking with large companies that have innovation teams, for me, it's fairly easy to break the crust and be able to then bring in my sales organization and engineering sometimes to sell the solution. But oftentimes the best way is to really hire people who are expert in the industry you're going after. And so progressively we hire the very strong product people and marketing people and sales people that understand deeply the manufacturing space. So they have to learn on the jobs, let's put it this way.
Yeah, yeah. Learning on the job is quite expensive.
Yeah.
Running right. Especially running a startup organization. If you think about the process of building an AI-enabled application in the industry, this doesn't have to be for you guys, but what do you see as the biggest challenge for folks in terms of building and deploying AI?
Well, there is sometimes there is a big gap between what people consider a prototype and deployed systems. And what we have found is that the companies that have a very clear roadmap for adoption for solving a particular problem are the ones that actually get out of this POC hell that sometimes startups are dragged into. And the reason is mostly cultural and historical, right? So when now AI is the thing. It has been the thing for a while, but you can imagine the CEOs of big companies playing golf with each other and say, hey, John, how is your company going? Well, we have AI here, here, and here. What about you? And if Bob doesn't have AI at the CEO level, he's going to yell to the VP of innovation in that big company and say, hey, why don't we have AI, right? So there is, this is a joking way to say that there is a lot of top-down pressure to be innovative, but sometimes this pressure doesn't have really the bottom-up, the bottom-up sort of match, okay, in a sense, coming from the real needs from the organization, right? And so when this happens, when there is actually a true need and an AI innovation and they meet in the middle, this is where the spark happens. But very often there is just a top-down pressure to put AI somewhere so that the company can say we have AI, right? But there is no real need from from the daily practice of the company to have that. And so the challenge for a startup is to understand when is this thing happening versus just the desire to put some crap, right, and say we have AI, right? So that's the challenge, and sometimes you go into this POC hell as a startup, and those are the dangerous things because you spin your wheel in vain.
Yeah, which is an interesting insight, right? Because I think a lot of folks think like, look, if it has support from the C-suite, then there's going to be some level of adoption. But while that's true, CEO could say, look, we need AI. The folks who work for the CEO will say, okay, we'll do a few POCs to satisfy that, but we haven't found a need. If they do have a need and it's a long-term need that can be solved, you kind of get over that, POC to long-term adoption. Definitely some good.
And sometimes, Darius, sometimes the bigger the company, the more dangerous they are, right? Because they have a lot of money to spend, and for them, $1 million to devote to some AI initiatives is not much. And so I've heard incredibly dumb thing that this large, I remember having a conversation with a large energy company, and they were pitched. They asked me, "Can you do this in the neuromorphic processor?" And then at the end of the day, I said, "Well, why?" And they didn't have an answer. you know, and everything that they say could have been done with a tenth of the price, and you know, in a much better way. But they had to brag about doing things, right? And so that's the danger, and the, you know, the antennas of people have to be up when this happens.
Right. Yeah. Definitely some good insight there. All right, yeah, and I don't want to be conscious of time, but I do have a couple more questions. One question is, you know, now that you guys have kind of, you got some customers on board here, you guys are up. Now I'm curious, the must-have tech tools. What are the tech tools that you've loved to have in the organization?
Tech tools? I think in terms of technology tools, we are pretty set. I mean, you know, if you ask me what do I want to have in the organization,
oh no, that you have currently. Yeah, not that you would like to have, but that you are currently using.
Technology tools. I think we would be dead without Slack. And the reason is that as we move remote, the communication between the team has been so impaired that, you know, without you know, Slack and Zoom, it would have been really tough for us to work. And I think, you know, you're going to get this answer from many people that they move their organization remote. But that's the truth.
Communication, that's the number one thing right now. Yeah, you definitely seen it in the valuations of a lot of these companies enabling remote work. Okay, and then I'm curious, one person who's inspired you or whose work you follow that is either in AI or in business.
Well, one of the most inspirational person that I met is one of my early investors, Tim Draper. He's a third generation venture capitalist in California. He's in the Silicon Valley, and he invested in our round in 2014. And you know, prior to us, he invested in companies like Skype, Hotmail, Baidu, and you know, later Tesla, SpaceX, and you know, super great companies that have kind of built a category by themselves, right? And when you talk to Tim, he gives you this, you know, he's not 20 years old, but he gives you the idea of the spirit of a teenager, in a sense, the enthusiasm of a kid that is discovering new things every day. And I think that you know, it's a pretty unique skills, and something that I consider as a mentor or as a master, something to you know, to always aspire, right? Because you never finish learning, and there is always something fresh and new in the technology sector that you should pay attention to. So that's a good spirit to have.
Okay. Yeah, interesting. That's the first reference to Tim Draper we've had with super helpful. And you know, that's the last question I had for you. I appreciate you sitting down and taking some time. I know you had to hop over to a coffee shop to knock it out, but yeah, thank you for taking out some time. For folks who want to learn more about you, learn more about Neurala, where should they go?
They should just type neurala.com, which is neurala.com.
Okay. All right. Awesome. Yeah, we'll make sure we get that up on the website too. But yeah, Max, thanks again for the time. This was super helpful.
Thank you, Darius.